Hi everyone, this is Aruna, Assistant Professor, Department of Arithmetic, Technology, SNS College of Technology. In my lecture series today, we're going to see about the instruction and instruction sequencing. So we already discussed about the memory operation in my previous lecture series. So what do you mean by instruction? So instruction is nothing but a set of action to be performed, that particular sequence. So we can say it is adding of two numbers. That is also one of the action, testing of particular condition, reading a character from a keyboard, or sending a character to the display or a monitor or a display screen. These are we can call it as a sequence. So here we are having a four different type of operation can be performed. One is the data transfer operation, that is a memory read and write operation. That is the data can be transmitted between the processor and the memory. So the next thing is ALU operation on data, and the next one is program logic and control, IO transfer. IO transfer in and out. Program sequencing is a loop, init, retrieve, call, retrieve. ALU is add, subtraction, multiplication, division, and or not. And your load operation, memory operation is a move, push, pop, exchange, load or store. These are the various type of operations. So these are the various different types of notations are available in our processor. This is assembly language notation. This is a basic instruction type. So always your instruction can be represented by four ways. One is 0 address, 1 address, 2 address, and 3 address. In 0 address, it will have only opcode. There is no source in the destination address. In your 1 address, you are having an opcode along with only one source and destination address. In your 2 address, your opcode along with one source address or destination. What is the difference between 1 address and 2 addresses? In 1 address, either opcode along with either it will have source or a destination. But in your 2 address, it will have a opcode as well as source as well as the destination. In your 3 address, your opcode 2 address, that is a source 1 and source 2, and you are having a destination. So in your 3 address, add the content of the memory location A and B and place the result in the location C. So this is how it can be worked. These are the various examples. So this is a very important question. What are the basic instruction types in a computer architecture? So here you are having another thing called as a straight line sequencing. So address in the first instruction is loaded to the PC. The program control circuit use the information in the PC to fetch and execute the instruction one at a time. In order to increasing address, this can be called it as a straight line sequencing. During the execution of instruction, PC can be incremented to the point of next instruction by 4 bit or 4 byte. So this is how an instruction can be executed. First, it will be loaded to the program counter. Through the program counter, it will be moved to the instruction register. Based on the instruction count, it will be sent to the instruction pipelining. And also, you are having an operand. So in your step 2, we are taking the data from the memory. That is a random access memory. So that can be processed over here. That can be processed, and the final data can be stored in our either in a register, then it can be moved to the memory. So this is how instruction can be executed. So this type of instruction only we can call it as a straight line sequencing. So usually in our instruction, we are having two types of instruction phase. One is a fetch phase and the next one is a execution phase. Fetch phase is it will get the data from the program counter, then it can be moved to instruction register. In your execution phase, your instruction register data is moved to the ALU unit. So only we can call it as this is a two phases of instruction set. The next thing is a branching. So while going for a branching is very important term is the branch target address. This is process fetch and execute the instruction at the new address. Only we can call it as a project branch target address. Branch type of instruction load a new value into the program counter, because we doesn't know may happen or may not happen. So the conditional process can cause as a branch if it is specified condition is satisfied. So that is how only we are saying a new address called as a branch target address. Your conditional code, so individual conditional code flag is 1 and 0. This 4 can be commonly used flags. N is a negative. If it is a 1 is set is that is a negative, or else 0 for positive. 0 set it for 1 if the result is 0, or else set it as a 1. So sorry, 0. B, that is a overflow bit. If 1 is the arithmetic overflow occurs, or else 0. C, carry, set it so 1 if it is a carry out of with operation, else we can set it as a 0. In the 4 cases only, a same 0 and 1 can be used in the different cases. So this type of a thing we can call it as a conditional flag. So that's all about the instruction and instruction sequencing. In next my video, I am going to detail explain about the addressing mode. Thank you for watching my video.